Everyone was waiting to see what would happen when they turned on this crazy powerful collider. Scientists have been waiting for a while. They were hoping it would change how we get what's out there in space. Back in September 2008, CERN turned on the Large Hadron Collider, LHC. It took a while to get it just right. Since then, it's been a big deal for learning about what makes up the universe. But recently, things got weird. When they cranked the LHC up to full power, something strange happened. People have come up with ideas about what it could mean, but no one knows for sure. The universe is full of stuff we can't explain. Like black holes, where gravity is so strong nothing can escape, and the Bermuda Triangle, where ships and planes disappear. In the 1900s, scientists started trying new ways to study what things are made of. In 1932, some scientists made the first atom smasher. Now, these things are common for seeing what's inside stuff. They crash particles together to get a better look at how they act. This helps us find out what forces and particles make up everything. CERN making the LHC shows how important these smashers are for learning about the universe. But, get this, something creepy might be happening. Some people think the LHC might be messing with reality, causing what's called the Mandela effect. This is when a lot of people think something happened one way, but it didn't. It got its name because a bunch of people thought Nelson Mandela died in prison in the 80s, but he actually died in 2013. People usually blame it on bad memories or social media, but some scientists think the LHC could have something to do with it. Even famous people are concerned about what the LHC could do. Stephen Hawking thought it could make black holes that could destroy everything. Another scientist, Dr. Carlo Roy, said the LHC could make particles that change stuff in ways we can't predict. Others, like Carl Schon, Arthur C. Clarke, and Barack Obama, have also wondered if it could cause something really bad. Because of all these worries, we need to think about the risks of using the LHC. Could it make the Mandela effect worse, or change the universe in other ways? The LHC, the biggest atom smasher ever, was made between 1998 and 2008 by over 10,000 scientists from over 100 countries. It started running in September 2008. It's made to test ideas about particles like the Higgs boson, look for new particles, and figure out some of the mysteries of particle physics. The LHC is like a big 27-kilometer loop with magnets and stuff that make particles go super fast. It shoots two beams of particles in opposite directions through tubes. The tubes go in a circle, guided by strong magnets. These magnets are super cold so electricity can flow without stopping. The LHC usually crashes protons together, but sometimes it uses heavy ions, like lead. This is done to study something called quark gluon plasma, which might have been around right after the Big Bang. Running the LHC takes a lot of power. CERN uses about 200 megawatts, which is like a third of what the whole city of Geneva uses. One of the biggest things the LHC has done is finding the Higgs boson in 2012. This particle helps explain why things have mass. Some people call it the God particle. The Higgs boson has no electric charge or color charge. It's made by the Higgs field, which is like an invisible force that gives particles mass. Finding it was a big deal. It proved some ideas about particle physics were right and opened doors for learning new things about the universe. Scientists are now trying to figure out if the Higgs field has anything to do with the Big Bang and how stable the universe is. The Higgs boson and something called the top quark might be able to tell us if the universe is stable. Scientists are planning to measure the top quark more accurately to predict what will happen to the universe. Also, the Higgs field might have made the universe expand really fast right after the Big Bang. But there's a problem. The amount of energy in space now doesn't match what theories about the Higgs field say. This issue makes us rethink how energy works in the universe. Because of all these worries, we need to think about the possible dangers of using the LHC, like the Mandela effect or other changes in the universe. The Large Hadron Collider is a big deal for particle physics. It's changed how we see space. But making and running it is just part of a bigger picture. To know how important the LHC is, we need to know about how particle accelerators have changed over time, the search for particles, and the ideas that guide physics now. Particle accelerators have a long history, from simple machines to the LHC. The first ones were basic. They were made to speed up particles enough to steady atoms. As technology got better, so did the machines. The cyclotron, made in 1930, was a big step. It let particles go in circles, getting faster each time. Then came some new inventions that made accelerators even better. All this led to colliders, where particles could crash together at super high speeds. Finding the W and Z bosons in the 1980s was a big moment for the LHC. These particles helped prove a theory about how some forces work. The discovery was a test of the standard model of particle physics, which tells us about particles and how they act. The standard model is good, but it's not perfect. It doesn't explain everything, like dark matter and dark energy, which make up most of the universe. Trying to figure these things out is why the LHC is here. Besides the Higgs boson, the LHC is also looking into physics beyond the standard model. One idea is supersymmetry, which adds a bunch of new particles to the standard model. This could fix some problems, like why gravity is so much weaker than other forces. Another idea is string theory, which says particles are actually tiny strings. This theory tries to combine all the forces into one. String theory is still just an idea, but it could teach us a lot about space and time. Studying heavy ion collisions at the LHC has shown us what quark gluon plasma is like. This stuff was around right after the Big Bang. By recreating it, scientists hope to learn about how the universe started. Because so many people are worried, we need to think about the bad stuff that could happen if we keep using the LHC. Could it really be causing the Mandela effect, or messing with our universe in other ways? The LHC, the most powerful atom smasher on the planet, was built between 1998 and 2008. Over 10,000 scientists from over 100 countries worked on it. It started running on September 10, 2008, and it's the most important part of CERN's bunch of accelerators. The main goal of the LHC is to check out different ideas about particles. This includes finding out what the Higgs boson is like, looking for new particles that some theories predict, and trying to solve some mysteries about particles. The LHC is a 27-kilometer ring with strong magnets and other stuff that makes particles go super fast. Two beams of particles go in opposite directions through pipes. The pipes go around in a circle, guided by strong magnets. These magnets use coils of special wire and have to be super cold, minus 271.3 degrees Celsius, to work right. The LHC mostly smashes protons together, but it also smashes heavy ions, mostly lead ions, sometimes. This is to study something called quark gluon plasma, which scientists think existed right after the Big Bang. It helps us understand what the universe is really made of. The LHC uses a ton of electricity, about 200 megawatts, which is like a third of what the whole city of Geneva uses. One of the LHC's biggest accomplishments was finding the Higgs boson in 2012. This particle is important for understanding why things have mass. Some people called it the God particle after a book came out. The Higgs boson is a tiny particle with no electric charge or anything like that. It's made by something called the Higgs field. This field is like an invisible force that gives particles mass. Finding the Higgs boson was a huge deal. Scientists had to look at data from trillions of particle collisions to find it. This discovery proved some of the ideas in the standard model of particle physics and opened up new ways to study the universe. Now, scientists are looking at how the Higgs field might be related to the Big Bang and how stable our universe is. The Higgs boson and another particle called the top quark are important for figuring out if the universe is stable. If it's not, things could change a lot way down the road. Researchers also want to measure the top quark really precisely to predict what will happen to the universe. The Higgs field might have caused the universe to expand really fast right after the Big Bang, too. The problem is, there's a lot less energy in space than theories with the Higgs field say there should be. This is called the cosmological constant problem, and it's a big challenge to how we understand the universe. That's why it's important to keep studying particle physics. Because of all these worries, we have to think about the bad things that could happen with the LHC. Could it be causing the Mandela effect, or changing the universe in other ways? The Large Hadron Collider is a big deal in particle physics. It's helped us understand the universe a lot. But building it and using it is just part of a bigger story. To really get why the LHC is important, we need to look at how particle accelerators have changed over time, how we've looked for fundamental particles, and the ideas that guide physics today. Particle accelerators have come a long way, from simple machines to the LHC. Early accelerators were pretty basic. They just sped up particles enough to look at atoms. As technology got better, these machines got more complicated. A guy named Ernest O. Lawrence invented the cyclotron in 1930, which was a big step forward. It made particles go around in a circle, so they could get more energy each time. Later, other scientists improved these ideas even more. These things led to colliders, where particles could smash into each other at high speeds. One of the most important things that happened before the LHC was finding the W and Z bosons in the 1980s. These particles are part of the weak force. It was the first time people saw real proof of some theories about how forces work. Finding the W and Z bosons was a big test of the standard model of particle physics, which describes the basic particles and how they interact. The standard model is good, but it's not a complete picture. It only describes 3 of the 4 basic forces, not gravity. It doesn't explain dark matter or dark energy, which make up most of the universe. Trying to fill in these blanks is why the LHC exists. Besides the Higgs boson, the LHC has been helping to explore physics beyond the standard model. One popular idea is supersymmetry, which adds a bunch of new particles to the standard model. Supersymmetry tries to solve some problems, like why gravity is so much weaker than the other forces. Another idea is string theory, which says that particles aren't points, but tiny vibrating strings. String theory tries to combine all the forces, including gravity, into one theory. It's mostly theoretical, but it gives us some ideas about how space and time work. The LHC also smashes heavy ions together to study quark-gluon plasma. This stuff was around right after the Big Bang. By making stuff like this again, scientists can learn about how it works and its role in how the universe grew. The LHC's discoveries even affect things like how we understand the Big Bang and the nature of cosmic inflation. The Higgs field probably caused the universe to grow really fast right after the Big Bang. If we can understand the Higgs field and how it interacts, we might be able to figure out what things were like when the universe was brand new. The LHC also helps us with neutrinos, which are weird particles that barely interact with anything. Neutrinos are important for understanding things like supernovas and how neutron stars are made. The LHC is also about more than just theoretical physics. The technology that was made for the LHC has led to inventions in other fields. For example, the World Wide Web was originally made at CERN to help scientists share data. Improvements in computers, data storage, and how data is analyzed have all come from LHC research and have been used in other industries. Even though the LHC has done a lot, it's also had some problems. When it first started up in 2008, something broke. One of the magnets had a problem, and it had to be shut down for a long time. But once it got running again, it's been giving us great data and new discoveries.